just imagine you're sitting in a classroom and the instructor is showing you some well-established demonstration. It's been done for years. And the professor flips a switch on the device and then just pauses and sits there and stares at something else and be like, what's going on? What's going on? Well, this is the story of how magnetism was discovered, or I should say electromagnetism was discovered, and magnetism generally was more fully understood. What happened is in a classroom demonstration, the professor, Osted, was demonstrating current. Okay, and current was an established thing. It wasn't a long established thing, but he was just hooked a battery to a wire, and it was making that current flow through the wire. So the professor was just demonstrating current flow, but had a little compass sitting on his table just by chance. I mean, it was not part of the demonstration. It was just by chance. And when he flipped the switch, the current started to flow. This compass, which was pointing north, suddenly pointed in a different direction. And the professor's like, huh. And started to play with it. Now, this just excites me because this is one of the more important discoveries in science. We use magnetism in so many different ways. So many of our medical imaging devices are based on magnetic fields. We have it's just a tremendous field of study. Your phone, every electronic device uses magnetic fields and things called inductors. We can use them in traffic lights and how they're turned on and off based on when you drive up. In scanning machines, all sorts of stuff use magnetic fields. And it was discovered by a careful observation. And so I wanted to start this by just encouraging you to think about being careful in your observations. You never know when the next time you're doing something that's well established and you just notice something. And by investigating that, you discover the next big thing in life. Okay, so with that as a background for this, let's see what happened. Basically, if you look down the wire, so this would be a top view, this would be a side view, this is a top view, and a compass is sitting right here. And if you hook this wire up to a battery so that current's coming out at you, then the compass is going to point that way. And if you place the compass over here, the compass would point that way. And if you place the compass over here, the compass would point that way, and so on and so forth, all the way around. You have this compass going around. You basically get these circular field lines where no matter where on that circle, it always points in this counterclockwise direction for that current flowing out at you. Okay? And we can use something called the right-hand rule we've used before for torque and things like that. When we use the right-hand rule, kind of describe that. And magnetic fields are all about right-hand rule, so we have to really practice with them well. So basically, if this is the current flowing out at you, I use my thumb to point out at you. Okay? Coming out at you. Right? And then you unfold your fingers to indicate the direction of the curl of the magnetic fields around that wire. And so with my thumb pointing out, my fingers must curve counterclockwise around this wire. If the field is going in, then my thumb would point down and my fingers would uncurl and they would curl clockwise around that wire. So that's how we can tell the direction. And we can show mathematically how to do it too, but I'm going to focus in this video just on these general patterns. And what you can do is if you stick the compass further away, it does deflect, but just not quite as strongly. And if you get it really far away, then it just points north. Okay? And so there's some distance dependence here, but the big thing that's unusual about it is that it has this curly motion, and it depends on if the charges are moving, if there's a current flowing. So if you turn this off, the magnet goes back to north. So magnetic fields depend on moving charge, not just charge, but moving charge. And they have these curly fields, and then they do get smaller with distance.